Welcome to the deep dive. So you've handed us a fascinating stack of sources here, and they all detail what looks like a massive shift in how large language models, well, interact with the digital world.
It's a huge shift, yeah.
And today we're talking about giving your LLM something that feels, frankly, overpowered. We're talking direct, secure, and pretty much unrestricted access to the applications and tools you use every single day.
It's really the technical equivalent of upgrading your LLM from just a helpful assistant, a passive one, to a full-fledged system administrator.
Right.
We're shifting from models that only generate text to models that can reliably execute really complex, multi-step actions across your entire tech stack.
That's the key difference, isn't it? We're moving beyond just writing emails. We're talking about connecting an LLM like Claude, directly to your personal Obsidian note vault.
Yeah, letting it search your notes, append content.
Or, and this is the part that signals a true paradigm shift for me, giving it the authorized capability to run specific security testing tools. Things like Nmap or WP Scan right from a Kali Linux environment.
And for anyone building with LLMs, this solves a foundational dilemma. I mean, if we want these models to be truly productive, to move data or start timers or run diagnostics, we have to connect them to external software.
But that's always been the hard part.
Exactly. Historically, that integration process has been messy, bespoke, and just, not standardized. Every single app required a different, painful workaround.
So that's our deep dive mission today. We are going to unpack the new industry standard that changes all of this, the Model Context Protocol, or MCP.
Yep.
We'll show you how incredibly easy it is to run this locally using Docker, and then we'll get into how you can build your own custom tools, letting LLMs perform these complex operations securely.
So let's start with the source of the pain. Why has connecting LLMs to our systems been such a hard problem to begin with?
Right. Where does the friction come from?
It fundamentally boils down to a massive mismatch, a mismatch between how applications were designed and how LLMs actually operate. We, as humans, we rely on graphical user interfaces, right? GUIs. They're friendly, they're visual, they're abstraction layers that hide all the complicated code underneath.
But LLMs are terrible at dealing with GUIs.
Absolutely. I mean, an LLM could theoretically process a screenshot of a GUI, but it's wildly inefficient, it's slow, and it's unreliable. They are fundamentally optimized for text.
So you could try giving them raw code access, I suppose.
You could, but that rarely works. They often lack the required permissions to execute anything, and frankly, no application is going to expose its internal source code just for an LLM to look at it.
Okay, so that brings us to the obvious middle ground, APIs, application programming interfaces. For decades, they've been the gold standard for program-to-program communication. Why aren't they the perfect bridge here?
Because APIs are built for developers talking to other developers. They're robust, sure, but they require a high degree of explicit knowledge.
Okay, an example.
Think about trying to create a new task. Using the API documentation for a project manager like ClickUp, it's extensive. It covers authentication, endpoint definitions, data structures, pagination. It is super intense.
And the LLM can't just read that documentation and, figure it out.
Not without a tremendous amount of effort. Even if you give an LLM API access, it still needs to write and then run executable code to interact with those endpoints.
So a human developer still has to get in the middle.
Yes. A human developer must code each specific interaction, like create a task, and then specifically instruct the LLM on how to call that bit of code correctly.
So if you want your LLM to connect to 10 different services, you're building 10 entirely custom, bespoke interpreters. That sounds painful and completely non-standard.
Precisely. You're building custom software wrappers for every single API, and the moment that API changes, your wrapper breaks. It's just not a sustainable model.
Okay, let's unpack this. If that's the mess, how does the Model Context Protocol, MCP, swoop in and solve this complexity trap?
MCP is what the industry desperately needed: standardization. It's a unified way to grant tools and capabilities to LLMs. Think of it like the USB-C of LLM tool access.
The one cable to rule them all.
Exactly. Anthropic created it, but it's rapidly being adopted as the industry standard because it directly addresses that complexity.
And the fundamental piece of infrastructure that enables this is the MCP server.
That's the key abstraction layer. The MCP server sits right in the middle. This server is the component that handles all the painful parts: the complex API calls, the coding, the credential management, the authentication.
So it's taking on all the technical debt.
All of it. It abstracts away everything the LLM should never have to deal with.
So the LLM no longer needs to scroll through 500 pages of the ClickUp API documentation.
Not at all. The LLM simply asks the MCP server to use a specific exposed task or tool. It might say, create a task in my ClickUp project. The LLM doesn't need to know anything about API endpoints or code or how the API key is being managed.
It effectively turns a complicated, multi-step API interaction into a simple verbal command. As one source put it, for the LLM, it's like just asking to click a button.
Yes, and because MCP is a standard, this is the powerful part. If an LLM client like Claude Desktop or a local model in LM Studio can connect to an MCP server, and most major clients are building this into, it instantly gains access to any application that exposes its tools via that server.
Regardless of the underlying complexity.
Exactly. It truly democratizes interoperability.
That is a massive architectural shift. It means the barrier to entry for tool use just drops to almost zero. So let's get practical. How do we actually start using this? The source material makes it clear that running an MCP server locally is surprisingly easy as long as you have Docker Desktop.
Docker Desktop is the foundational requirement, yeah, whether you're on Mac, Linux, or Windows. But for Windows users specifically, you have to be running WSL2 for Docker to work properly.
And there's a setting you have to enable, right? This is still new.
It's very new. It's cutting edge, so you have to dive into the settings and enable the brand new MCP toolkit. And it's in the Docker Desktop Beta Features section.
Once that's enabled, we can get access to a catalog of pre-built tools. The main example used in the sources was connecting to an Obsidian Note Vault.
All right, the Obsidian MCP server is available right there in the Docker catalog. The setup took like 2 quick steps. First, you install the Obsidian community plugin called Local REST API.
Okay.
And second, you just generate and paste in the API key. Once that's done, the MCP server automatically exposes tools to the LLM that are described in completely plain natural language.
So things like use Obsidian append content or simple search.
Exactly.
And this is where the magic happens, because now we connect our LLM client, say Claude Desktop, to something called the Docker MCP Gateway.
That gateway is the central point of contact. Once the client is connected, you can ask Claude a question that requires an action, like create a note in my Obsidian vault detailing the best way to make French press coffee.
And what we see then is Claude understands it needs a tool, it asks you for permission, and boom, instantly, the note appears in your local Obsidian vault.
And the AI never saw the API key. It never saw the underlying code, but it successfully executed the task. It's the perfect demonstration of that abstraction layer working.
And this goes way beyond just note-taking.
Oh yeah. The catalog includes external data tools, which are essential for research. Things like DuckDuckGo Fetch for grabbing content from a URL, Brave Search, and even specific parsers like YouTube transcripts.
And this capability isn't limited to powerful cloud models. The sources showed tests connecting local open source models like Gemma or DeepSeek running through LM Studio to that same local MCP server.
That consistency is the real test of a standard. I mean, the LLM's raw intelligence might vary. A smaller local model might need a better prompt. But the fact that the tool call works identically means you can start executing complex chained commands.
Like that example where the user chained 2 tasks. Find the top 10 best Japanese restaurants in Dallas using the DuckDuckGo tool, then create a note in my vault with your findings using the Obsidian tool. That's a multi-step operation from one sentence.
Exactly. It uses one tool to gather external data, and then immediately uses a second tool to store the results locally. It's seamless.
Here's where it gets really interesting. Because if the existing catalog of tools is great, building your own custom MCP servers is the next level. Why limit yourself?
This is where the power of modern LLMs, like Claude Opus, comes in as a development assistant. The sources really emphasize that you don't need to be an expert coder. You can generate a custom server extremely quickly just by giving a powerful LLM a specific, detailed prompt.
The first example was intentionally simple. A dice roller, just to prove the concept.
Right. The AI generates all the necessary files. The Docker file, the requirements, the core Python server script, a read eam, and a YAML catalog entry. Then you just build a container using Docker build.
Now, this is a technical deep dive, so there is one important manual step here when you're working locally inside Docker Desktop.
There is. You have to manually edit the local hidden registry.yaml file to reference your new custom server. And then you have to make sure the client configuration is updated to include that new custom catalog file.
It's a necessary little hack to integrate a non-catalog tool, but the payoff is instant. You can ask the LLM to roll 2d6 or generate a set of D&D stats, and it just does it through the custom server you just built.
Then they escalated the complexity. The next test was a toggle timer, a tool to control a real-world time-tracking app using its official API. The goal was simple: start, stop, or view timers, all via chat.
And this brought up a crucial security insight.
Yeah, the security of handling API keys, you never want those exposed in your code.
Right.
This is handled beautifully by the gateway. You use the command docker MCP secret set and then the variable name and your API key. This lets the gateway securely manage the credentials outside of the script.
So the key is never in the code.
Never. The LLM then successfully views the currently running timer and can stop or restart it with simple commands. It just proves the API integration works flawlessly and securely.
And the ultimate demonstration of power in the sources was building a Kali Linux authorized testing MCP server.
This moves from productivity to, well, serious utility. By setting a Kali Linux container on the local machine, the LLM is given the capability to run authorized testing tools within that controlled environment.
The source material did note that the AI initially tried to include its own safety guardrails in the generated code, which had to be tweaked.
It did, yeah. But once those initial adjustments were made, the LLM successfully executed some really complex cybersecurity testing tasks.
Like what?
We're talking about asking the LLM to run an Nmap scan across a local network range, like a 10.70.2.024 subnet, or asking it to run vulnerability scanners like WP-Scan or SQL Map against an intentionally insecure target, like a local DVWA install.
So it elevates the LLM from being a coding partner to being a literal executor of security tasks based purely on verbal instructions.
It's an incredible scope of what's possible when you abstract the complexity away. It moves the LLM from simply providing theory to actually performing an action.
So what does this all mean? Let's take a deep dive into the nerdy details of the mechanism itself. First, a core efficiency question. Are these server containers running all the time, just chewing up resources?
No, and that's a key design feature for efficiency. The MCP server containers are ephemeral.
Ephemeral.
They are spun up briefly only when the LLM makes an active request to use a tool, and then they're spun down immediately. If you watch the Docker process list during a tool call, the container just pops up for a fraction of a second and then vanishes.
Wow, so minimal resource overhead.
Almost none.
Okay, that's incredibly efficient.
Yeah.
Now let's talk communication transport. How are these local services talking to each other so fast?
When you're running locally via Docker desktop, the communication is it's direct and optimized. It uses a very low latency transport. Specifically, they use standard input and output DOUTSTIN via the command line.
So they're just passing text back and forth.
Basically, yeah. They're exchanging messages through pipes. The messages themselves are in a standard format called JSON RPC.
JSON RPC, it sounds complicated.
It just means JavaScript object notation, remote procedure call.
Yeah.
It's a very simple, lightweight way to exchange structured data and trigger functions. The huge benefit of using this pipe communication locally is that there is virtually no network latency. It's the fastest possible local connection.
But obviously, remote MCP servers, like if you were using an external API hosted on the web, they can't use local pipe.
Exactly. Remote communication requires a full web server setup. It uses standard HTTP or HTTPS for the client-to-server requests. But for the server to send updates back to the client, say to notify it that a long-running task is done, it relies on something called server-sent events, or SSE.
SSE. Why is that necessary for remote tasks?
Because over the internet, the server needs a way to push real-time updates back to the client without the client constantly asking, "Are you done yet?" SSE lets the server keep an open connection and just push data streams events back to the client instantly. It's much more complex to set up than the local pipe communication, which is why the Docker setup is so convenient.
Which brings us back to the Docker MCP gateway. It seems to be the central brain coordinating all of this.
It is the orchestration layer. And without it, the complexity would just spiral out of control. I mean, think about it. Without the gateway, you'd have to configure and authenticate your LLM client separately for the Obsidian server, the Dice server, the Toggle server.
Instead, our clients Claude, Cursor, LM Studio, they only need to connect to one central Docker MCP gateway instance.
That centralization is key. The gateway manages the catalog of all the different registered servers, directs traffic, and crucially, it provides that centralized, secure management of all your secrets and API keys we talked about.
And the sources showed you can even run that gateway remotely, extending its reach beyond your local machine.
Yes. You can run the gateway as a standalone Docker container, completely separate from Docker Desktop, just by specifying the transports option. And what does that do?
It makes all your locally configured tools, including your custom dice roller or your Obsidian Vault, available over the network, usually on a specific port like 8811.
This opens up the highest impact automation scenario. like connecting an external automation platform, say N8N, to that remote gateway URL.
The possibilities become truly limitless at that point. N8N can now chain commands across multiple custom tools, combining their unique capabilities. Imagine telling it, use an external tool to find the highest rated Airbnb in a city, use the toggle tool to log my research time, and then automatically log all the findings in my Obsidian vault.
And that sequence is now possible.
It's possible, yeah, using simple interconnected APIs, all facilitated by that one MCP gateway.
This is a highly valuable, cutting-edge technical skill. It fundamentally shifts how we empower LLMs. The knowledge of how to deploy and build these custom tools using the Docker MCP gateway, especially combined with platforms like N8N, that feels like a major new frontier. It's the gold rush opportunity in application integration. It makes the LLM not just a smart brain, but a powerful pair of hands that can run your entire digital workflow.
So if the Model Context Protocol standardizes and simplifies tool access to this degree, we have to ask a provocative final thought for you to mull over. How quickly will LLMs move from being simply generative assistants to becoming the sole operating system interface for virtually every technical application we use?
Potentially rendering traditional graphical interfaces completely obsolete for complex, multi-step tasks.
It's a fundamental question of interface design. We're moving from clicking to simply asking.
Something powerful to consider until our next deep dive.